Okay, welcome everyone to 3.4. I'm here in Dallas, Texas, more specifically Arlington, Texas, getting ready for Game 6 of the World Series tonight. My Dodgers, and you can see I've got my Dodger visor on, got my Dodgers Hawaiian shirt on, all ready to go. And actually, if you look out the window here, there's my son. He's zooming also, just like you guys. If you look, you can't really see, but anyway, way out in the corner there, probably can't see it all that well, is actually the stadium. We're about a mile, a little more than a mile away. And that's where we'll be headed tonight. Can't wait. Yeah. Anyway, enough of that. Let's get going here. I'll get Ryan out of the picture there. But if you can send me, he went actually. Would be a fun extra credit. He went to AT&T Stadium, which is where the Dallas Cowboys play in the NFL. And so if you can share with me by email an interesting fact about AT&T Stadium in Dallas or Arlington, I guess, again, where the Cowboys play, I will give you an extra credit point. And there are some real doozies, I'll tell you that, because he came back from the tour with them. And if you remind me in class, I'll show you a picture of a funny picture of him there. Okay, but let's go ahead and take a look at 3.4. And so we're graphing linear equations in what we call standard form. So linear equations meaning a line. So we're graphing lines using what we call standard form. And we're going to get into what that is. But let's go ahead and warm up first. And this, I want you to write a rule to relate the variables in the table for the following functions. So we're told they're functions, right? And then we'll determine if it's a linear or nonlinear function, okay? So in other words, what would the rules be here if you're looking where x is increasing by 1 and y is increasing by what? It's increasing by going 3 and then 5 and then 7. So what would you write that as? Maybe as x increases by 1, y increases as the square of x, right? Because that's another way to look at it. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay. Do you think that that would be linear or nonlinear if the y and the x are not increasing at the same constant rate? Hopefully you said nonlinear. So it's a nonlinear function. Okay. How about number 2? Try number 2. Okay, so we're back with it. And what do you think? What do you think? What did you notice here? Did you notice that this goes 1, 1, 1, and this goes 6, 6, 6? So what is that saying? That's saying it's plus 6, plus 6, plus 6. So that's saying what? It's as x increases by 1, y increases by 6. Do you think that's linear or nonlinear? Well, hopefully you said linear, right? Because each time you go over to the right one on the graph, you're going to go up 6. And think about it, if you went onto Desmos and you actually graphed those points or graphed them on any kind of coordinate system, even if you just drew it, you would see that the points would connect and form a line. All right, great. So let's do this one. This one's kind of fun. Write all the pairs of numbers that you can think of that have sum of 5 as ordered pairs. So go ahead and write those. So one of them would be what? Like 0, 5, right? -1, 6 would work as well. So think of some of them. Okay, so here's some examples, right? There's actually an infinite number if you think about it, because we didn't have to use just integers. We could have used, 2.5, 2.5. Okay, now go over on this coordinate plane and whatever numbers you thought of, plot them. Okay, so plot those points. Okay, so I have my examples there and I plotted mine. Notice they form what? They all line up, right? So this would be a linear function, right, that passes the vertical line test. What do you think the equation of this line would be? Right, so if we did, what about like x plus y equals 5, right? Would that work for all of these? If I plug in, for example, 3 for x and 2 for y, would 3 plus 2 equal 5? Yeah. Would 2 plus 3 equal 5? Yeah. Would -3 for x and 8 for y, -3 plus 8 equal 5? Yeah. So that would be how we would write it. This is called writing an equation in standard form. Okay, and we're going to talk more about that in a bit. Okay, so our learning target is going to be able to graph an equation in the form of ax plus by equals c. And again, that's standard form, okay? So you can work with the partner, and obviously it can be your imaginary partner if you like, or maybe your Dodger partner. Maybe you're working with Justin Turner or Jock Peterson. Ooh, how about that? Or Clayton Kershaw. Okay. Anyway, so you sold a total of $16 worth of tickets to a fundraiser. Good for you. That's awesome. Glad you did that. Hope it was for a good cause. I'm sure it was. You lost track of how many of each type of ticket you sold. So there's more than one type, right? There's adult tickets that are $4 each and child tickets that are $2 each. Okay. So what we do know is that we could write this kind of as like what we would call like a number sentence, I guess, as the number of adult tickets times the cost of adult tickets plus the number of child tickets times the cost of child's tickets should equal what total? Yeah, $16, right? Okay. So let's let X represent the number of adult tickets, and let's let Y represent, the number of child tickets, okay? So if that was the case, how would we write that as an equation? Did you get 4x plus 2y equals 16? Remember, the cost of adults is 4. The x is representing the number of adults plus 2 times y equals 16. Okay, great. Now let's see what the different combos would show. And in this case, can you sell half of a ticket? No. Okay, so what if you sold 0 adult tickets? Okay, how many child tickets would you have had to have sold to get to 16? Well, 4x becomes 0, so we'd have just 2y equals 16, divide both sides by 2, and y would equal 8. And that should make sense, right? Because $2 times 8 tickets is $16. Okay, well, what if you sold 1 adult ticket? Then this would have a value of 4, which means this has to have a value of just 12, right? Well, 2y, if it was equal to 12, means y would be what? 6. Okay, try filling in the rest of it. Okay, hopefully for 2, you had 4. And if you sold 3 adult tickets, this is worth 12. So this is only worth 4. And so you would have 2 and 4 and 0. Okay. Notice, would this be linear or non-linear? As x goes up 1, y goes down 2. It's constant rate of change. It's not altering. So that would be linear. Okay. So, I kind of got ahead of myself here. So plot the points from the table. Okay, so you do that over here. Go ahead and plot it. Pause and plot. Okay. And hopefully it's something that looked like that. Notice I'm not using the second, third, or fourth quadrants because this is a real life situation, right? We're not going to have negative tickets sold, right? Or cost or anything like that. Okay. Okay. So think about, what do you think the equation could be for this one? Well, we already said it, right? We said it was 4x plus 2y equals 16. Okay, so the points create a line, right? The slope, you may remember that term, and we'll get into that more, is -2. Slope is how much you rise or fall over how much you move horizontally, which we call run. So notice we go down to the right one. So this would be a slope of -2 over 1, which equals -2. -2, 1, -2, 1, -2, 1. Wouldn't you expect that the slope for a line would stay the same because it's straight, right? Okay, now let's talk about x and y intercepts. You may remember this from pre-algebra, but an x-intercept of a graph is the x-coordinate of a point where the graph crosses the x-axis. So the x-coordinate of the point where the graph crosses the x-axis. So where would this graph cross the x-axis? Oh, right here, right at 4, 0. So the x-intercept in this case, we would say, is just 4, right? Because it's the x-coordinate. What's always the y-coordinate where a line or whatever crosses the x-axis? Isn't it? That would be somewhere along here, right? Could be over here or here, and wouldn't it always be 0? So we don't list the 0. Okay, similarly, the y-intercept is the y-coordinate of where the point crosses the y-axis. Y-coordinate, y-intercept, y-axis. So that would be up here. So what is the y-coordinate of this point, which is 0, 8? Yeah, it's 8. So we'd say the y-intercept is 8. Okay, good. All right, so the standard form for a linear equation is ax plus by and c, where we're going to plug in numbers for a, b, and c, okay? And by the way, a, b, and c are not both 0. One of them could be 0, and we'll get into that situation later in this unit, but or later in this section actually, but both can't be 0. Because then you'd have 0 plus 0 equals, and then it's like weird because c could be something else and that wouldn't make any sense. Okay, so one way that we can graph equations is to use the x-intercepts, okay? So the x-intercept, again, of a graph is the x-coordinate of a point where the graph crosses the x-axis. So think about where that is here, right? That's going to be right here. And what's true of every single point that's on the x-axis? Its y-coordinate, its ordinate is always 0, right? Okay, so it would be in the form of, they just used a, but a comma 0, right? 5 comma 0, or 7 comma 0, or 11 comma 0, or if we had an x-intercept over here, you know, it'd be negative 7 comma 0, or whatever. Okay. And the y-intercept is where the line crosses the y-axis. That would be up here, right? And we use b to represent that. And what's the x-coordinate always going to be for a point that's on the y-axis? Yeah, it's always 0, right? Because we don't move left or right. So it's always in the form of 0 comma b. Okay. So how does that help us in graphing? Well, to graph the linear equation of something that's in standard form, ax plus by equals c, all you do is find the intercepts and draw the line that passes through the 2 points. So you plot the 2 points and you connect the dots. You get to play connect the dots. You never thought you'd be playing that again, but here you are. Okay, so how do you find the x-intercept? Well, you set y equal to 0, right? Because if you set y equals 0, that just leaves the one variable, right? If y is 0, by goes to 0, and you just have ax equals c. Easy to solve for x there. Just divide both sides by a. To find the y-intercept, what do? You set x equal to 0, right? Because remember, it's always going to be a point. Whoop. It's always going to be a point. Oops, sorry about that. Let me move this over so you can see it. It's always going to be a point that crosses the y-axis, which means the x is going to be 0. So if I plug x equals 0, this goes away, and I just have by equals c, which means that the y-intercept is going to be c over b, okay? Which leads to another kind of shortcut. If you're in standard form, won't it always be the case that the x-intercept will equal c over a, right? Because the by will always go away when you set y equal to 0. So it's always going to just be what c over a is equal to. And the y-intercept is always just going to be, you know, where ax goes to 0, because x would be 0, would just be c over b. So that's kind of a shortcut way, but you can always work it out and do it if you want. So here we go. So we're used intercepts to graph the equation of 3x plus 4y equals 12. All right. So let's set x equal to 0 to find the y-intercept. So if I set x equal to 0, what does y become? Hopefully you said 3, right? Because it would be 4y equals 12, divide both sides by 4, and we get y equals 3. And let's set y equal to 0. So 4y becomes 4 times 0, or 0, which leaves us with 3x equals 12. Divide both sides by 3, and we get 4, okay? So now we have 2 points. So what should we do with those 2 points now? Yeah, we should go graph them. So go graph those 2 points, and then use a straight edge and draw a line and put arrows on your lines, because remember, these continue on forever. And you should have something that looks like that. You probably don't have the -8, 9 labeled as a point yet. That's okay. Don't worry about that right now. But you should have these, and you should have a line that's extended. Okay. So here's the next question. How do we know we did this right? Okay. Well, if a line contains all of the ordered pairs that make this equation true, then shouldn't any point on the line, if I figure out what the ordered pair is, I can plug those in for X and Y, and it should balance, right? So here I extended my line. It looks like this line goes through the point -8, 9. So that should be a solution to this equation. So let's see if that works. So I plug in, by the way, notice the blue and the white, huh? Notice that, yeah. So we'll find a point, figure out its coordinates. We did, -8, 9. We're gonna plug them into the equation. So let's actually plug those in, and then we'll check it. So let's see. I thought I would have done that somewhere, but anyway, I didn't. Let's see. 3 times -8 would be -12, right? I'm sorry, -12, -24. 9 times 4 would be 36. What's -24 plus 36? 12. Check, check. It works, right? I think I probably have that here. Oh, I guess not. Okay. And why does that work? Again, the line represents all the solutions of the graph. So again, I could go down to this point right here, which is what? -7, comma, -2, and plug that in, and it would work. Okay. If I plugged in 7, 3 times 7 is 21. 4 times, what did I say? -2 would be -8. And you combine those together. Actually, I guess it doesn't go through that point. But anyway, it would work. How did that work out? -7, -2 should be working. Oh, no, it's not. I'm sorry. It's negative. Let's see. I would go down 3. So, I see. It's actually -8, -3 is where it goes through. So or 8, -3. So if we plug those in, let's do that. 3 times 8 is 24. 4 times -3 is -12. 24 and -12 equals 12. Check, check. Sorry about that. I was just thinking it went through that point, but it actually doesn't. It goes through that one. I guess you gotta be careful of that, which is another reason why using Desmos is great if you want to, graph when you're doing your big ideas. Okay, so let's try using intercepts here to graph the linear equation, okay? So let's start here with 2x minus y equals 4. Okay, so plug in 0 for x, that goes away. What does y end up equaling? Careful. So you said -4, okay? Because negative of -4 equals 4. If you plug in now 0 for y to find the x-intercept, 2x equals 4, so x equals what? 2, good. Okay, go plot those points and then draw a line. And then I guess I'm doing 2 on 1, aren't I? So let's go over and do this one. So do the x and y intercepts for this one over here. So pause the video, move this down a little bit. Hopefully you got 0, -3, and -9, 0. Then plot that one. Should be a different line, right? And there's our 2 lines here. This one is over here. I should have color coordinated these. And this one is over here, okay? And if you wanted to check to make sure you did it right, you could find another point on your line and then plug those coordinates in, okay? All right. This would be a good place if you want to take a quick break and stop, go stretch or do something. If you feel like you're losing your attention, remember you can stop anytime. That's what's so great about doing it on video like this. But this would be kind of a nice natural place to stop for a sec. But here we go. All right, so there are situations where, unlike here where we have diagonal lines, right, they go up and over at the same time, or down and over at the same time. Here we have horizontal lines and we have vertical lines, okay? And if you think about it, a horizontal line is always going to have what? It's always going to have the same y coordinate. Every single point on here, they've labeled it B, would be like here, 0, B. Over here might be 3, B. Over here might be 5, B. Over here might be -1, B. Notice how that the y coordinate is going to be the same no matter what. It's horizontal, right? It doesn't rise or fall. It stays flat like the horizon. Okay. So whatever that point is, or whatever that coordinate is for all the points, whatever the y coordinate is for all the points, that's how you label it. So it would be y equals, let's say this was not 0, b, but 0, 3. It would be y equals 3. Okay. So another way to remember this is we name the line based on what all the points on the line have in common. Here, the y coordinate is always the same. So we would say it's y equals b, or like y equals 3. Okay, what about vertical lines? Vertical lines mean straight up and down, right? Well, similar thing here, right? Here, it's not all the points that are on the line have the same y coordinate. They're actually all different. They all have the same what? The same x coordinate, the same abscissa. In this case, we've labeled it a. Okay, so like this point is a comma 0. Up here would be, I don't know, 3 comma 0. Up here would be 5 comma 0. Down here would be -1 comma 0. Okay, so we label that as x equals a. Again, we name the line based on what all the points have in common. So that's important to remember. Okay, so if I asked you to graph y equals 4, what would you do? Okay, well, there's no x in there, right? So that should be telling you something. That's telling you that that is a line where every single y coordinate is 4. So if you think about that, just pick any 2 points that have the same y coordinate of 4. It could be 0, 4, 3, 4, it doesn't matter, any of them. And then connect those and extend the lines and put arrows on them, and you're going to get something that looks like that. Okay, doesn't matter which points you pick. Okay, well, what about a line that's x equals -2? What is that telling us? Remember, there's no y in there, right? So it's saying that every single point has an x coordinate of -2, okay? So hopefully you drew something like this. Remember, the thicker line is the one we're graphing. The thinner ones are just the axes. So here's -2 comma 0. And if you put another point like -2 comma 4, doesn't really matter which 2 points, but they're going to have an x coordinate of -2. It's going to draw and make a vertical line. Okay. All right. So let's go back now and let's try a couple of word problems here. We got this. All right. You're planning an awards banquet for your school or for your Dodgers as they come back into town and COVID's done and we can actually have a celebration. So you're planning an awards banquet for them. You need to rent tables to seat 180 people. Okay. The tables come in 2 sizes. There's small tables that sit 6 people and large tables that seat 10. Okay, so the equation, they're actually giving that to you, that represents this situation is 6x plus 10y equals 180, okay? And x is the number of small tables and y is the number of large tables. So let's analyze that for a second. 6 would be the number of people, x would be the number of small tables. So for example, if there were 10 small tables, 6 times 10 would mean there were 60 people sitting in small tables. 10 is the number of people that sit at the bigger tables, the large tables, and y is the number. So if there were, 12 people sitting at or if there were 12 large tables, then there'd be 10 times 12 people sitting at large tables, or 120, okay? All right, so let's graph the equation, okay? So, and they want you to do that by finding the x and y intercepts. So again, to find the x-intercept, what do? You set y equal to 0. Okay, so think about what that would get us, right? If 6x, and this goes to 0, because y is 0, 6x equals 180 means we divide 180 by 6, and we would get 30, okay? And then to find the other intercept, right, we're going to find the y-intercept, we're going to set x equal to 0. Well, if x is 0, then 6 times x becomes 6 times 0, which is 0. And we're left with just what? 10y equals 180, divide both sides by 10, and y equals 18. Okay, so then graph those. So notice what we got. Here's that 30 comma 0. Here's the 0 comma 18. If you connect the dots, that would tell you the possible solutions to this equation. Okay. Notice again, we haven't gone to negative x values in the second quadrant or anything down here or anything down in the fourth quadrant where y's would be negative, right? Can you have a negative number of large tables or a negative number of small tables? No, of course not. It's a real life situation. Okay. So the next question I have is every single point on here a solution to this equation of 6x plus 10y equals 180? And the answer is yes. No matter what point you picked here, if you figured out what the ordered pair was, it would work. But would that work for this situation? Can you have part of a table? No. So what we have to do is we have to look, in order to find 4 possible solutions, we have to look on here and see where we have integers as our x and y coordinates. So let's see. Looks like maybe right there is. And what's that? That's 10, 12, right? Oh, by the way, that was the example I used up here. Remember when I said, let's say x was 10 and y was 12? Notice 6 times 10 would be 60. 10 times 12 would be 120. 60 plus 120 equals 180, okay? So see if you can find another one, okay? All right, so again, because only whole numbers or integer values of x and y make sense in the context of this problem, besides the intercepts, it appears the line passes through 10, 12, that's the one that I just mentioned, which was right there, and 20, 6, looks like right there. And think about it, if we had 20 for x, 6 times 20 is 120, 10 times 6 is 60, 120 plus 60 is 180, so that works. And then obviously you could have 0 small tables and 18 large tables, or you could have 30 small tables and 0 large tables. Okay, so there's 4 possible solutions that work to get you to your 180 for your Dodger Award banquet. Okay. So, and again here, the x-intercept shows that you could do the 30 small tables and 0 large tables. This shows 0 small tables and 18 larges, okay? And again, notice how they all check. All right, great. So what if you decide to rent tables from a different company and you had the equation 4x plus 6y equals 180. So again, x is the number of small tables. So how many people are sitting at a small table? It's a really small table. There's only what? 4. It's like a card table or something. And the large tables only have 6. So I want you to go ahead and graph the equation using your x and y intercepts and then interpret that, what that means. What is that telling us? Okay, go for it. Okay, well, hopefully you graphed it. And if you set x equal to 0, y is going to be 30. So you have a point that you would plot of 0, 30. If you set y equal to 0, x is going to be 4x equals 180. So x equals 45. So we have 45 comma 0. We can draw our line and then we could look for other possible situations that would work. And it looks like right there, there's one that's what, 15 comma 20. Notice 15 times 4 is 60. 20 times 6 is 120. 60 plus 120 equals 180. Okay, and I think there's another one right there and so on. So, but the x and y intercepts are showing 2 of the possibilities. And I think there's one there and there's one there at 30 comma 10. 4 times 30 is 120. 6 times 10 is 60. 120 plus 60 is 180. All right, I think that covers it. Go Dodgers. Hope you enjoyed 3.4 and I'll see you soon.